Hey everyone, in this video I'm going to be reviewing how to solve a linear system by looking at a graph and then also by the substitution method. So in the first example, we need to solve the system using the given graph of the two equations. We actually aren't even given the equations written out here, but that's fine because we have the graph already for us. And we know that when we're looking at a graph of two equations, if we want to find the solution that works for both equations, or in other words, the solution to the system of equations, we need to look at where the two lines intersect. So you can see that the blue line and the green line intersect at this white dot in the middle. So now in order to write the solution to the system, I need to make sure I write it in my coordinate form, which is where I put x first, comma, and then the y value in parentheses. So I'm going to look at my graph and figure out what the x value is by looking at the horizontal axis at the top. So I can see that my white dot, if I go up to the x-axis, it's at x equals 1. So the first number in my coordinate is going to be 1. And then to look for the y value at the white dot, I'm going to go left to see what value I'm at the y-axis. And I can see that I'm at the value -3. So I put -3 second in my coordinate. Remember, it's always x, comma, y. Okay, so for all of our systems that we solve, we're going to always write our answer in the coordinate form, x, comma, y with parentheses around it. All right, so now that we know how to solve by looking at a graph, let's make sure we can solve when we don't have a graph. So for my next example, I'm going to solve a system of equations using the substitution method. And the equations that are given to me are 7x minus 3y equals 17 and y equals 6. So substitution tells us that we're going to need to substitute in values for our different variables in order to solve. So I can see that with this system, I've already actually been given one of my solutions. So I know my solution, I'm going to have to write the x term, comma, the y term. And as you can see, I already have one solution being y equals 6. One of my equations is telling me the solution for y. So I don't know my x value yet, but I do know that the value for y is 6, just because I got kind of lucky with this one. They already told me in the equation that y is equal to 6. So the system told me y is 6. Now I just have to figure out what x is. Now, again, since it's called the substitution method, that means I'm going to take 6 and I'm going to substitute it in for y in the first equation. So I'm going to write out my first equation, but instead of writing y, when I see y, I'm going to substitute in using parentheses, replace the y with the 6. Remember, when you substitute values into equations, you always need parentheses to make sure you do all of the correct operations. So I take my 6, I write out my first equation again, and I replace the y with the parentheses 6. So now I can simplify my equation and solve for x. So I have 3 times 6 here that I need to simplify. I know 3 times 6, if I do that in a calculator, gives me 18. Now I'm just solving a two-step equation, and we know to solve the two-step equation we need to get x by itself. So we start by adding 18 on both sides. So I bring down the 7x equals 17 plus 18 gives me 35. You can always check that in a calculator. And then the last step to get x by itself is divide both sides by 7. And here we get x equals 35 divided by 7 would give me 5. So that means the second part of my coordinate point is x equals 5. So in that empty spot in my coordinate, I'm going to put 5. So my solution to this system is the coordinate point 5, comma 6, the x value 5 and the y value of 6. Now if I go on to my example 3, I can see this one might take a little more work because this time they didn't give me an equation that just tells me one of the solutions. So this time my equations are -4x plus 6y equals -12, and then y equals x minus 2. Well, the good thing about this is I do already have, in my second equation, I already have y is already isolated. It's already by itself. Just like in the last one, even though it's not telling me y is equal to a specific number, it is telling me that y is equal to x minus 2. And since I already have y by itself in one of my equations, this is going to make substituting really easy. So this equation is telling me y is equal to x minus 2. So just like before, even though we don't have just a number, this time instead of just the number 6 like we substituted in before, now we have the whole expression x minus 2. So instead of just substituting in a number, we're actually going to go ahead and substitute in the whole expression x minus 2 and for y. Okay, and then that's going to let us solve for x. So just to say that one more time, I already have an equation with one of the variables isolated, and in this case, that's y. Y is by itself, and it's telling me y is equal to x minus 2. Now, just because it's not telling me y is equal to a number doesn't mean I can't substitute. It's telling me y is equal to an expression, x minus 2. I can still take that expression and substitute in that expression for y in my first equation. So I'm going to write out my first equation, negative 4x plus 6, and now I see the y, so I have to pause because I know I'm trying to replace y with my expression x minus 2. So once again, we always need parentheses, and then we write our whole expression x minus 2, and then don't forget the equals negative 12. It's very similar to what we did before, it's just we are substituting in x minus 2 instead of just a number by itself. Now, as you can see, we have now an equation with only one variable, x. And I know when I have an equation with only one variable, I can solve for that variable. So that means I'm able to solve for x now. And that will allow us to find part of our solution. So to solve for x, one of the first things we need to do to simplify is distribute that 6. So I'm going to carry down the negative 4x, and I'm distributing the 6. So 6 times x gives me 6x, and 6 times negative 2 gives me negative 12. And then I bring down my right side of the equation. Now I can combine like terms, negative 4x plus 6x, those are like terms because they both have an x. And if you do negative 4 plus 6 in your calculator, you get 2. So that means these combine to give me 2x. And then I bring down my minus 12 and the right side of my equation. Now I have a two-step equation. I need to solve for x. So I'm going to add 12 on both sides. Negative 12 plus 12 actually gives us 0. So I carry down my 2x on the left, and then I end up with 0 on the right. Now I just divide both sides by 2, and I get x equals 0 divided by 2. That gives me 0. So that gives me part of my solution. So I know I have my solution is an x, y coordinate point, and I now have the x value 0, but I still need to find my y value to finish my solution. Well, the great thing is I already have my second equation already has y by itself, and now I have a value for x that I can plug in. So I'm going to take my second equation, y equals x minus 2, and I'm just going to take that x equals 0 and substitute it into that equation because that's going to allow me to get my solution for y. So then I have y equals, substitute in the 0 for x, and 0 minus 2 gives me negative 2 for y. So see how that second part was really easy because we already had the equation with y by itself. We always want to use that equation to help us find y. Once we have x, we just substitute it in there, and we really quickly find that y is negative 2. So that's our solution. Now in my last example, it's a little different. This time it's just asking, is negative 5, negative 9 a solution to the following system? And the system I'm given is x plus 3y equals 9 and 2x minus 5 equals y. Well, I know that my coordinate point is giving me an x value and a y value. The solution it's giving me is that x is negative 5 and y is negative 9. So if I want to know if it's a solution, I can just substitute in both of these values into my system and see if it works. So this one isn't asking us to find the solution, it's just asking us if this is a solution. So to do that, we just substitute into both equations, see if we get true statements. So for the first equation, I have x plus 3y equals 9. I'm substituting in negative 5 for x, and then a negative 9 for y. So 3 parentheses negative 9. Now I just need to evaluate the left side and see if it gives me 9. So negative 5 plus 3 times negative 9, well, that gives me negative 27. So I'm actually going to write minus 27. And then negative 5 minus 27, if you check in a calculator, you get negative 32. equals 9, which obviously that is not true, false. And then we can check also for the other equation. We can substitute in 2 times -5 minus 5 equals -9 is what we're substituting in for y. I just do the steps on my left side and see if it gives me -9. 2 times -5 gives me -10 minus 5 equals -9. -10 minus 5 gives me -15, which again is false. So since we got two false statements when we plugged in our possible solution, the answer is no. -5, -9 is not a solution. And keep in mind, you can always check any of your work by doing this. Like I could go back to example 3 and substitute in 0 and -2 to both of my original equations and make sure it gives me true statements. That's a great way to check your work when you're working on your own. Find your solution using whatever method you use and then check it by substituting in the x and the y value that you find into both equations and making sure you get true statements. Okay, hopefully that helped you review the graphing and substitution methods for solving linear systems.